Weather on Earth is caused by Earth's rotation on its axis and its revolution around the Sun. The axis around which the Earth rotates goes from North Pole to South Pole through its center and is slanted at an angle of 23.5 degrees. Earth rotates towards the east, and that's why the Sun and Moon appear to rise in the east and move westward across the sky. The Earth rotates on its slanted axis once every 24 hours, which is one day. As it rotates, it also revolves around the Sun. Each revolution takes 365 days, which is 1 year. The Earth spins at constant speed from west to east. The speed at the equator is around 1670 kilometers per hour. But we do not feel that it is spinning. Why? This is just like when you are traveling in an airplane that is moving at a constant speed, and you walk to the bathroom and you do not feel that you are moving because you and the airplane are both moving at the same speed. Also, suppose you are in India and it is night. As the Earth rotates, India moves from west to east, and finally the sun's rays hit India. So you experience sunrise. The sun seems to rise above the horizon. Then as the Earth rotates further, the sun seems to move westward, and finally at noon, the sun is just above the head. The sun has not moved. It is India that has moved more and more to the east. Finally, in the evening, India moves further to the east, and the sun's rays do not hit India. This is when the sun sets. Again, the sun has not moved. It is India that has moved further east, and the sun is now out of view. You may ask, is the tilt of Earth axis to the left or to the right? The answer is, it is neither. To one observer, the Earth axis appears to tilt to the right. But to another observer at another location in space, the axis seems to tilt to the left. The axis on which the Earth rotates does not change as it revolves around the Sun. Currently, it is fixed at 23.5 degrees tilt from the vertical line as shown. Due to this axial tilt, the Sun shines on different latitudes at different angles throughout the year. This causes the seasons. How did the axial slant of Earth happen? One accepted theory is that the Earth was born about 4.54 billion years ago. At that time, or shortly after, when a Mars-sized object collided with Earth, it knocked off a chunk that would become our moon. It also tilted Earth sideways a bit, so that our planet now orbits the sun on a slant. Now look at this picture. It shows how the Earth revolves around the sun. At point A, the axis direction in the north is away from the sun. This means the northern hemisphere gets sun rays at an angle and gets less heat from the sun, so it has winter. The southern hemisphere is closer to the sun and gets more heat and has summer. At point B, the axis near the northern hemisphere is closer to the sun and hence gets more heat from the sun and has summer. While the axis near southern hemisphere is pointing away from the sun and gets less heat and has winter. This is how the northern and the southern hemisphere each has 4 seasons: summer, fall, winter, and spring. The picture shows the seasons in the northern hemisphere. The northern hemisphere is more exposed to the sun during the summer, and it is less exposed to the sun during the winter. The maxima occur during the 2 solstices, as the Earth's tilt is then parallel to the direction of the sun. Both hemispheres are equally exposed to the sun during the 2 equinoxes, as the Earth's tilt is then perpendicular to the direction of the sun. Remember, when it's winter in the north, it is summer in the south, and vice versa. During equinox, Day and night are of same length. On summer solstice, day is longest and night shortest. On winter solstice, day is shortest and night longest. Northern spring means southern fall. Equinoxes and solstices are opposite on either side of the equator. The March equinox is the spring equinox in the northern hemisphere, marking the start of astronomical spring. In the southern hemisphere, on the same date, it is called the autumn equinox, which marks the start of fall. Axial precession. Earth's axis appears stable, but it actually ovals very slowly, like a spinning top. It takes Earth's axis about 26,000 years to complete a circular oval. This oval is called axial precession. During this cycle, the tilt of the axis varies between 22.1 and 24.5 degrees. Earth's axis helps determine the North Star, and axial precession helps change it. Currently, for instance, Earth's axis points towards a star called Polaris. Polaris, which gets its name because it is almost directly above the North Pole, is the current North Star. Polaris will not always be the North Star, however. The Earth's axis is slowly ovaling away from Polaris. In another 13,000 years, it will point towards the new North Star, a star called Vega. Arctic weather. The climate of the Arctic is characterized by long, cold winters and short, cool summers. However, in the 6 months from the September equinox to March equinox, the North Pole receives no sunlight. During the winter months of November through February, the sun remains very low in the sky in the Arctic or does not rise at all. Where it does rise, the days are short, and the sun's low position in the sky means that even at noon, not much energy is reaching the surface. What would happen if the axis around which the Earth spins was not slanted, but was vertical from the North Pole to the South Pole? The answer is that there would be no seasons on Earth. This also would mean very sorry state for humanity. The Earth would be very different and really bad if that was the case. Without the axial tilt, the relationship of the Earth to the Sun would always be as it is on the day of the equinoxes. This is when the Sun is exactly above the Earth's equator. Now we get equinoxes twice each year, and as we orbit the Sun and our relationship changes between the solstices, we get the seasons. If this did not happen, it would be a very different world without seasons.